Welcome. Here we're going to begin talking about some complex numbers as well as operations applied to complex numbers. First things first, we need to know what a complex number is. A complex number in standard form has a real part, some a value, plus an imaginary part, bi. So what we see here, a plus bi, real plus an imaginary part, represents a complex number in standard form. Complex numbers are a very large set of numbers. Complex numbers can have imaginary numbers inside of them or can be just a real number with some b value equal to 0. So if b was equal to 0, we would not have that imaginary part. Without the imaginary part, it's just a real number. If we do have an imaginary part, then we call that an imaginary or complex number. Now, with imaginary numbers, we have imaginary complex, such as -1/2 minus I or 5 plus 2I, versus pure imaginary. And pure imaginary numbers have no real part. That a value in both of these is equal to 0. The real number system, we can have irrational numbers, which are numbers that have decimal places that do not terminate, or rational numbers with a decimal place that does terminate could be written as a fraction. So complex numbers is really just taking into account that we can have these imaginaries combined with real numbers. Algebraic operations hold across complex numbers. When you are simplifying, in this case we have two examples, A and B, we're going to simplify. When you're simplifying complex numbers and applying these operations, essentially all you need to do is treat I as a variable. You're just going to perform these algebraic operations as you would, simplify any other algebraic expression. So for example A, we have 3 minus 2I plus -2 plus 6I. You'll notice that each of these numbers has a real and an imaginary part. Adding these two complex numbers is as simple as adding each portion. So I'll say 3 plus -2, I'll add my two real numbers, plus I'll have -2I plus 6I. So 3 plus -2, that will simplify to 1, and -2I plus 6I will give us plus 4I. So the sum of these two complex numbers is 1 minus 4I. Looking at this next problem, treating it the same way, we have -7 plus I minus this entire complex number, -2 minus 5I. One thing you'll notice is the minus is in front of that second complex number. That's going to need to distribute. So in this situation, what I now have is -17 plus I have plus 2 and plus 5I. At this point, I'll just add my real parts, -17 plus 2, that is -15, and I plus 5I, that will give us plus 6I. There is one last step that can be applied to this problem. You should notice that 3 is a factor of both 15 and 6. I'm going to factor out -3, and that leaves me with a positive 5. Pulling -3 out of 6 leaves me with -2I. So either of these two answers are completely acceptable, although moving forwards in algebra and towards trig and calculus, we're always looking to factor and simplify when possible. So here, -15 plus 6I, that would be perfectly acceptable in the computer for your homework, but recognizing there is a GCF and factoring that out is important moving forward. Let's look at one more example. For this problem, we're going to simplify and again write our answer in the a plus bi standard form. What you'll notice here is I have 1 minus I, and this operation is multiplication, so times the quantity -2 minus 6i. So I have a binomial times a binomial, and when I multiply, I need to make sure I distribute. When we think about multiplying and distributing, we have a binomial times a binomial. We oftentimes use the acronym FOIL to help us remember how to multiply these terms. So my two first terms, that will be 1 times -2. Those each come first in each binomial. My outer terms, that's going to be +1 times -6i. My inside, my inner terms, that is -i times -2. And then my two last terms, I have -i times -6i. 1 times -2 is -2. 1 times -6i gives us -6i. I times -2 is +2i. And then lastly, we have -1 times -6i. That's going to give us +6, and I times I is I squared. So now let's look at simplifying what we have. I do have two like terms in the middle, -6i plus 2i. Those can be combined, and that would give me -4i. We need to recognize something that we know about I squared. I squared is equal to the value -1. So looking at what we have here, I have 6 times -1. So now I have -2 minus 4i minus 6, or rather -8 minus 4i, combining like terms. -2 minus 6 gave me -8. And we should recognize, especially from the last problem, that we can factor a GCF out here. So I'm going to factor out a -4, and that leaves me with +2 plus 1i, or just I. And this would be my final answer for multiplying. All right, so FOIL is just an acronym that helps us match up each of those 4 terms. If you do struggle with foiling, I would like to bring to your attention the box or area method. So what I could essentially do here would be to take this first term, I'm going to write 1 and -i, as well as the second term, -2 minus 6i. Making this box, that's just a method that allows me to match up my terms and make sure that I'm getting all 4 of those 4 terms. So you'll notice we get the same 4 terms here that we got in this previous row up there. So -2 times 1 gave me -2, -6 times 1 is -6i, 2 times -i, -2, -i, that's going to be +2i, and -6 times -i gives us +6i squared. So you'll see these terms right here are the same as these 4 terms in the box. All right, well, I hope that helps you understand. We're going to do a little bit more multiplication in the following, the last video in this section, and then we'll also talk about dividing with complex numbers. Thanks for listening. Good night and have a pleasant tomorrow.